Hello students, my name is Chandra and today we will study a very important topic in mathematics that is called binomial theorem. And in this chapter, binomial theorem, we will study a very important concept that is called the general term of binomial. Okay. And this topic is going to be very important from our JEE point of view. We will see that many questions are there that came from this topic. Okay. So let's start the topic. Before going to the general term of binomial theorem, we will see a little bit of binomial theorem expansion for natural index. Okay, let's see. In our binomial theorem classes, we have seen that the binomial expansion, let's say x plus y to the power n, and we were doing this expansion for the natural index. That means here n should be natural number. Sorry, n belongs to natural number. We are doing this expansion for n's to be natural number. We know that the expansion becomes like nc0 x to the power n plus nc1 x to the power n minus 1 into y to the power 1 plus nc2 x to the power n minus 2 into y to the power 2, and so on. It will go up to ncn x to the power 0 y to the power n. Here also we can write it as, here in this part also we can write it as, we can add one term that is called y equals to 0. So this is our binomial expansion for natural index. Natural index means what? We will doing the binomial expansion whose power will be a natural number. Okay, that means for an example, if we take an example, let's say we are having an example, we need to expand the expansion of a plus b to the power 5. So it will become 5c0 a to the power 5. Y to the power 0 or b to the power 0 means ultimately it will become 1, right? So we will move to the next term, that is 5c1 a to the power 4 b to the power 1 plus 5c2 a to the power 3 b to the power 2 plus 5c3 a to the power 2 b to the power 3 plus 5c3 a b to the power 4 plus 5, sorry, it will become 5c4 5c4. Now the last term will be, now the last term will be 5c5b to the power 5. So that means this is our binomial expansion for natural index. That means the power of the binomial should be natural number. Okay. Our main important focus in this topic is general term of binomial expansion. So now we will see what will be the general term of binomial expansion. So here we got our expansion, right, for x plus y to the power n. So this is our expansion. X plus y to the power n is nc0 x to the power n plus nc1 x to the power n minus 1 into y to the power 1 plus nc2 x to the power n minus 2 into y to the power 2 plus go on, go on, go on, go on. Ultimately, it will go up to ncn y to the power n. So this is our binomial expansion. Okay. In any expansion, the terms that are separated by plus or minus signs are called the terms of that expansion. Okay. The expression that are separated by plus or minus signs are called the terms of that expansions. So here we will see that, here we can see that this is our one term, this is our one term, this is our one term, this is also our term. So that means the term that came in the first part or first position is called first term. So let's denote the first term as T1. Let's denote the second term as T2. Don't get confused. Okay, do not get confused. This complete, do not get confused. This complete term is term 2. Okay, so this is our term 2, this is our term 3, so on. It will go, it will go, it will go. But in any position, we will come to know that if you look properly in any position, we will see that this is our first term. In the first term, 1, we see that the lower suffix of NC0 is 0. Here, the lower suffix of the coefficient of x to the power n is 0. In the second term, here in the lower suffix of NCR, we see that it is 1. Okay. In the third term, we see that the lower suffix is 2. Sorry, that means what? In any term the lower suffix will be 1 minus of the term we required. Okay, that means what? We make it generalize. We can make it generalize as, let's say, if I want to find the term r, if we need to find the term tr, that means in any term tr, it will become ncr minus 1. That means the lower suffix will be 1 less than the term we required. Okay. Okay. Then what will be the next part? Here in the next part we will see that it will be x to the power n minus 1 and y to the power 1. That means we will get x and y together. So x and y. Now we have to decide what should be the power of x and y. Here we can see that if lower suffix is 1, the power becomes n minus 1. If lower suffix is 2, the power of x become n minus 2. If lower suffix is 1, the power become n minus, sorry, if lower suffix is 0, the power become n minus 0. So here, if the lower suffix is r minus 1, the power will become n minus r minus 1. That, okay. In the next part, what will be the power of y? We can see that if the lower suffix is 1, the power is 1. If the lower suffix is 2, the power of y is 2. If the lower suffix is n, the power of y is n. So here we can write it as, here we see that the lower suffix is r minus 1, so it will become r minus 1. So this is going to be our general term of binomial expansion. This is called general term of binomial expansion. So this is our binomial expansion's general term. General term of binomial expansion. This is our general term of binomial expansion. Okay? This is our general term of binomial expansion. Now we will try to make this formula more in an easy way. We will try to write this formula in a more easy way so that it will become very helpful for us to find the solution or to solve the given questions. Okay. So let's make it easy to remember. Here we can see that we are having formula TR is equals to NCR minus 1 x to the power n minus r minus 1 and y to the power r minus 1. To make it more catchy or more handy, what we will do, we will replace the r, we will replace r by r plus 1. If we replace the variable r by r plus 1, then the whole expression will become t r plus 1 is equals to ncr x to the power n minus r into y to the power r. Same formula, no difference, same formula. But only just in place of r we have replaced it by r plus 1, and last we got the rth term and this will become t r plus 1th term. So we can write it as r plus 1th term of binomial expansion, of binomial expansion. So this is going to be our general term. This formula and this formula, no difference, both are same. But we will try to use this formula because this formula is very handy to remember. Okay. So we will move on to the next step. So what we got finally, general term of general term of binomial expansion. Okay. We can say it as general term or we can say it as r plus 1th term. R plus 1th term of binomial expansion. Binomial expansion, and it goes tr plus 1 is equals to ncr x to the power n minus r into y to the power r. So this is our binomial expansion formula. Okay. So before solving the question, we will remember one more important point, that is called binomial coefficient. That is called binomial coefficient. So let's see about binomial coefficient. Binomial coefficient. The term NCR that we have seen in our binomial terms, general term, is called basically binomial coefficient. This term is called binomial coefficient, right? So what is the formula for finding the binomial coefficient? NCR is equals to n factorial by r factorial into n minus r factorial. Now what is factorial? What is factorial? Factorial is represented by either this sign or this sign. Okay. Now what does factorial means? If we write 4 factorial, that means we will multiply 4 into 3 into 2 into 1 up to 1 natural number. Okay. What does 15 means? 15 factorial. 15 into 14 into 13 into 12 into so on up to 2 into 1. Okay. So this is our theorem for factorial. Now, we have to remember one very important point. The value of 1 factorial is equals to 1 and the value of 0 factor is also equals to 1. Similarly, here in NCR, we will remember some formula. The value of NC0 is always equals to 1. The value of NCN is always equals to 1. The value of NC1 is equals to n. The value of NCN minus 1 is equals to n. And we also have to remember one very important formula, that is 1CR is equals to NCN minus R. And for the sake of general term, this much will be enough, and by using this much of information, we can able to solve the questions that we will discuss now. Okay, so let's see one question. Okay, here we can see that we have a question that came in JEE 2023. It says the coefficient of x to the power minus 6 in the expansion of this. So we have given a binomial expansions. We have given a binomial expansion. Sorry, something is missing here. I think power is missing here. For the binomial expansion, we need power. Okay, one second. Okay, what is the question? The coefficient of x to the power minus 6. Okay, the power is, I think, 9. Okay. So in this question, we need to find the coefficient of x to the power minus 6. For solving this question, we will use the concept that we have seen just now, that is the general term of binomial expansion. So what is the general term of binomial expansion? The general term of binomial expansion is tr plus 1 is equals to ncr into x to the power n minus r into y to the power r. So this is our general term for binomial expansion. We will use this formula to find, the solution of this question. Okay. So this is our general term of binomial expansion. So here in place of x and y, we are having our own expansions that is given in the question, that is 4x by 5 plus 5 by 2x square, and we are having power as 9. Here what we need to find the coefficient of x to the power minus 6. For this question, if we write the general term, that is tr plus 1, the value of n is 9cr, and the value of x here is first term as 4x by 5 to the power n minus r, and here the n is 9, so it will become 9 minus r, and the second term is 5 by 2x square it will become r. So if we simplify this, 9cr 4 by 5 to the power 9 minus r into 5 by 2 to the power r into x to the power 9 minus r into 1 by x square to the power r. So finally, we can simplify it as 9cr 4 by 5 to the power 9 minus r into 5 by 2 to the power r into x to the power 9 minus r minus 2r. That means it will become 9 minus 3r, or we can simply write it as 9 minus 3r. 9 minus 3r. 9 minus 3. So this is our general term of binomial expansion. And what we need to find in the question, it is saying that in the question we need to find the coefficient of x to the power minus 6. That means the power of the x will should have to be minus 6. So from this concept we can take it as 9 minus 3r is equals to minus 6. So it will become 3r is equals to 15. So the value of r is become 5. So we got the value of r as 5. For the power of x to be x to the power minus 6, we have to take the value of r as 5. Okay. So here if we put the value of r as 5, then what will be our value? So our coefficient, let's take different marker. Coefficient, let's write that in the above portion. Coefficient of x to the power minus 6. This whole thing will become the coefficient of x to the power minus 6. It will become 9c5 into 4 by 5 to the power 9 minus 5. That means it will become 4. Here 5 by 2 and it will become r. R means what? 5. Okay. So our question become 9c5. 9c5 means 9 factorial by 5 factorial into 9 minus 5 factorial. That means 4 factorial into 4 to the power 4, 5 to the power 4 into 5 to the power 5 into 2 to the power 5. Okay. So here it will become 9 into 8 into 7 into 6 into 5 into 4 into 3, or we can write it as 9 into 8 into 7 into 6 into 5 factorial. Here it will become 5 factorial into 4 factorial. 4 to the power 4, we can write it as 2 to the power 8 by 5 to the power 4 into 5 to the power 5, 5 to the power 5 by 2 to the power 5. Okay. So 5 to the power 5, 2 to the power 4. Here 5 factorial got cancelled. Let's take the another page. Let's take another page. So 9 into 8 into 7 into 6. 9 into 8 into 7 into 6 by 4 factorial, 4 into 3 into 2 into 1 into, it will become 2 to the power 8, 2 to the power 5, so it will become 2 to the power 3, 2 to the power 3 into 5 to the power 4, 5 to the power 5, so it will become 5, 5 above there. Okay, so it will become 5. So our final answer will be 4 2 ja 8, 2 2 got cancel, 3 2 ja 6. Now we need to do the calculation. 9 7 ja 63 into 2 into 8 into 5. So 2 3 ja 6, 2 6 ja 12, 8 5 ja 40. So our final answer will be 6 4 ja 24, carry 2, 4 2 ja 8 9 10, 0 carry 1, 4 1 ja 5 0 4 0. So our answer became finally 504. 5040. So let's check the answer if our answer is 5040 or not. Where is the answer? Yes, the answer is 5040. You can take a look. The answer is 5040. So we have learned a very important topic, that is general term of binomial expansion, and this topic is very important from the point of view. If you take a look at the previous question that came in JEE exam, you will come to know that the JEE have used many times this formula to give the questions. So this formula is going to be the very important for us. The formula is called general term of binomial expansions. Thank you. Thank you very much.